Hello, this is Rick, and this is a RoboSim Pro video on converting M&G codes to pdl2 programs. Alright, so the first thing we'll do is we will load in a cell. We'll just make a cell just as a sample cell that we can then load in M&G codes and see what we've got. So here we just have the robot and a plate, and then we have a teacher in the center, and we will use the teacher as a reference frame, and then we just select the M&G code reader. Okay, so the robot's selected. We select the teacher as the reference frame. We pick the file, and you notice that the file, for some reason, it's too large for pdl2, so we copied it and renamed it copy_G1, so it's just shorter. Okay, so we'll just load in the copy. Okay, so if we import it, we first want to check some global variables, sort of the rapid speed, the default speed rate, joint speed, and then we've got the log level. So we'll click OK on those, and then we'll just import all of these M&G codes. So what happens is each one appears in the on-screen program as its own line. We can see that there's about 4,500 lines of points in this M&G code file. So we'll just read them all in, and we convert the G01s to the straight motion, and then we just have it as straight motion, and so when we execute it, it'll be a straight motion to that. We're going to make the frame sizes real small because I've done this before and it looks better. Well, you can also trace the tool. We're going to call this a sealing gun. It looks like a welding gun, but we're using it as a sealing gun here. And in fact, it could be a welding gun because it turns out looks like this is additive manufacturing, as we'll see. So it could be a welding application where they're actually welding the part, or it could be more like converting a 3D printer using robotics instead, and then we could scale this up, which is the advantage of robotics. Okay, so these are the points. As we read them in, we trace, and we can see basically what it's doing is it's creating this shape, this outline. It also creates a copy of the program, so we'll just move that over there. But as it's going, you can see that it's just one on top of the other. It just has like 3 wide and is creating this shape. So what I'm going to do is I'm going to pause the video for a little bit and then come back when it's just about done, and we'll see a little bit more what the final shape looks like. Here, let me go pause it. Well, first, see, you can see the general shape. Okay, so then we restart it, and you can see that it's done. It's about 7 or 8 levels, and it kind of looks like probably a turbine blade or something like that. And we don't know what kind of process they use, but it was some kind of it's either welding or just a regular 3D printer. But we can now use the Kamau robot to do that. So it's pretty handy. Then what we can do is when we're done simulating, then we can save the program, and as we save the program, it'll automatically convert it to pdl2. So here's a close-up of the different layers. So you can see they're 3 thick and they're about 7 or 8 high. A lot of little frames in there. So let's save the program. You press the middle button on the save, and we've done it before, so it's going to replace it, and it's going to create now these Kamau programs that then we can run on a Kamau controller. So let's take a look at them. Okay, so here's you know, there's a lot of points that we have to define, and then we have to move to them, move fly to them, and it's got different parameters. And then at the very end we have a little routine that programs it. So if you have an M&G code program that you want to convert to PDL2, this is a good application. All right, thank you.